There's a kind of silence that doesn't feel empty but charged, like the air before a storm. For months now, the world's most powerful telescopes have been watching something move through our solar system. And yet, nobody's talking. Not NASA, not ESA, not even the people who usually can't wait to tweet a discovery. Why? Why has every major space agency suddenly gone quiet? And what exactly is 3I Atlas, this small visitor from the deep, whose name now lingers like a half-forgotten warning? In the next moments, you'll hear a story that begins with a comet, but ends with something far larger, about science, truth, and the strange ways we deal with the unknown. Because sometimes the real mystery isn't what we see in the sky, it's what we choose not to say about it. This film will take you through 12 chapters, from the blurred image above Mars that no one wants to explain, to the corridors of NASA where data turns into silence, to the private satellites that might already know more than we think. You'll see how fear, politics, and the limits of our instruments all weave together to create a silence so vast, it echoes across nations. And maybe, by the end, you'll start to wonder whether silence itself is the universe's way of speaking to us. If you've ever looked up at the night sky and felt both awe and unease, if you've ever wondered why the truth sometimes hides behind polite press releases and quiet pauses, then this journey is for you. We'll take it slowly. No fear, no sensationalism, just curiosity, the pure kind, the one that built telescopes and wrote the first equations of the stars. So let's begin where silence began, with one small dot above Mars, a flash of light so faint it almost didn't exist, and yet, somehow, it changed the tone of an entire planet. Let's begin the story of 3I Atlas in the silence that followed it. Part 1, the question that shouldn't be silent. It began, as most great mysteries do, with a pause. Not the kind of pause you take to breathe, but the kind that feels like the world itself is holding its breath. In March of this year, a faint visitor entered our solar system, a traveler from the deep, the third interstellar object ever detected by humankind, its name, 3I Atlas, and yet, unlike the ones before it, something strange happened. The scientists stopped talking. No press conferences, no headlines, no excited chatter across NASA's social feeds. Only silence. A kind of quiet, so coordinated, it almost felt deliberate. And that's when the question emerged. When did silence become the language of discovery? Science, by nature, thrives on curiosity and conversation. When the first interstellar visitor, Oumuamua, was detected in 2017, NASA released more than a dozen public updates within the first week. Astronomers from Harvard to Hawaii published papers, podcasts, and interviews. When 2I Borisov passed in 2019, it was on magazine covers, trending hashtags, and televised documentaries within days. But with 3I Atlas, things changed. The first detection came from a Russian observatory in October, the confirmation from ESA weeks later. And the official NASA page? A single paragraph quietly posted and never updated. No images, no analysis, no follow-ups. Even the agencies known for enthusiasm, JAXA, CNSA, ISRO, all stayed quiet. It wasn't absence of information. It was absence of reaction. And that silence in itself became data. Because silence is never neutral. In science, as in life, Silence often means someone is still trying to understand what they've seen. Remember when the JWST released its first deep field image in 2022? The entire world stopped for a moment. People cried, laughed, and felt infinite. That's what discovery used to sound like. The sound of collective wonder. Now imagine the opposite. Imagine you find something extraordinary, but the world around you just lowers its voice. No one celebrates. No one denies. They simply step back, as if the universe whispered something they weren't ready to repeat. That's what this silence feels like. Not empty, but heavy. Sometimes silence is not a cover-up. Sometimes it's caution. The same way a sailor grows quiet before the storm, not from fear, but from respect. Maybe the scientists aren't hiding the truth. Maybe they're listening, carefully, to a universe that doesn't like to be interrupted. Because discovery isn't always about finding answers. It's about knowing when to stop and listen. And that listening, that sacred, almost human instinct to pause, began with a single, blurry image taken high above Mars. A streak of light that wasn't supposed to be there. A moment so faint, it nearly slipped through history unnoticed. Until someone looked closer and realized the silence had a shape. Part 2. A dot over Mars. The image that shouldn't exist. It started with a picture that wasn't supposed to mean anything. A quiet night above the red sands of Mars. A satellite, the European Space Agency's Mars Express, was performing one of its routine sky surveys, the kind it's done thousands of times before. And yet, in one frame, something appeared. A small, pale streak. So faint, you could have mistaken it for a scratch on the lens. But it wasn't. It was moving. At first, no one noticed. The image sat buried in a folder, marked anomaly, waiting for review. Weeks passed. Then one engineer, half out of curiosity, ran the data again and saw the same streak in the same position across multiple exposures. It wasn't dust. It wasn't glare. It was real. And that tiny blur floating just above Mars would soon become one of the strangest puzzles in modern astronomy. To understand why this was so strange, you have to know how space photography works. When a comet passes by, light behaves predictably. It scatters, it glows, it stretches into a tail as the sun's heat vaporizes ice into gas. Even at great distances, every comet leaves a fingerprint, a visible coma, a bright nucleus, a trail of dust whispering across the void. But this image didn't match any of that. There was no tail, no glare, no signature of gas or dust, just a faint, clean line, like a whisper drawn across a vacuum. Engineers recalibrated their instruments. They tested for lens reflections, cosmic rays, software noise. Nothing explained it. Then someone cross-checked the timing. The coordinates matched perfectly with 3I Atlas, the interstellar traveler. And that's when the silence began to make sense. Because this wasn't supposed to be visible. By every known model, 3I Atlas should have been far beyond the detection range of Mars Express. Too small, too cold, too distant. And yet there it was, glowing faintly, above a planet that shouldn't have been looking at it at all. It reminded me of the famous Pioneer anomaly back in 1980, when NASA's spacecraft, long thought to be drifting predictably, began to slow down ever so slightly by forces no one could explain. For decades, scientists argued, recalculated, debated, and in the end, the cause was something beautifully human: heat. The tiny warmth of the spacecraft's own body pushing back against the void. Sometimes, mysteries in science aren't about aliens or secrets. They're about patience, about how long we're willing to sit with the unexplainable without rushing to explain it away. Maybe that's what this image teaches us, that not every anomaly is a threat. Some are invitations. Invitations to look deeper, slower, with less arrogance and more wonder. Because if we only look for what we expect, we'll miss what's truly extraordinary. The universe, after all, doesn't make mistakes. It only waits for us to notice what's already there. And as the engineers stared at that lonely streak above Mars, one question began to ripple through every agency's silence. If our instruments are seeing what they shouldn't, then what else might they be missing? The answer, it turned out, was hiding in the unlikeliest of places, inside the quiet corridors of NASA itself. Part 3. NASA's timeline. Gap. When data becomes politics. Silence doesn't always mean secrecy. Sometimes it just means someone is waiting for permission to speak. When 3I Atlas appeared above Mars, many expected NASA to step forward, to bring clarity to the world's questions. But days passed, then weeks, and still no official statement, no press release, no update. A small note appeared quietly on NASA's Minor Planet Center. A brief confirmation of orbit, time-stamped, technical, emotionless, and then nothing. It was as if the world's most talkative space agency suddenly forgot how to speak. People began to notice the pause, not because it was loud, but because it wasn't. You see, NASA has a rhythm, an internal heartbeat made of public briefings, tweets, and data drops. But with 3I Atlas, that rhythm broke. And when a rhythm breaks in an institution built on communication, it means something deeper is happening beneath the surface. In truth, NASA's silence wasn't just about the comet. It was about timing. Every image, every data set, every line of observation passes through layers: scientific review, internal verification, public affairs, even political clearance. Take the Hubble telescope, for example. When it first detected Oumuamua in 2017, NASA's first statement came just 6 days later. For 2I Borisov in 2019, it was even faster, 4 days. But with 3I Atlas, the gap was 39 days. Why? Part of the reason lies in bureaucracy. NASA isn't just a team of scientists. It's a constellation of departments, data analysts, communicators, legal advisors, even international partners. Each wants to make sure the story is safe, verified, presentable. But there's another quieter reason. NASA's words carry global weight. A single statement from them can shift markets, fuel conspiracies, or spark panic. So sometimes, they choose silence not out of secrecy, but out of strategy. In 1996, NASA held one of its most famous press conferences, announcing possible fossilized bacteria in a Martian meteorite. For one glorious day, humanity believed we had proof of life beyond Earth. Then the backlash came, harsh, political, unforgiving. Budgets were threatened, reputations were shredded, and since then, NASA has learned discovery isn't just about science, it's about survival. That memory still lingers in every office, every lab, every cautious voice before a microphone. So when 3I Atlas appeared, perhaps the lesson from 1996 whispered again: Don't speak until you're absolutely sure what you're saying. Maybe that's the real heart of this story. That in science, as in life, timing is everything. The truth isn't just about what we find, it's about when we dare to share it. There's a humility in that, a kind of patience that feels frustrating, but also wise. Because when knowledge moves faster than understanding, chaos follows. And sometimes the bravest thing a scientist can do is wait. But NASA's silence didn't exist in isolation. Across the world, other observatories began to slow their communication too. ESA stopped releasing raw images. China's National Space Agency archived their last mention of Atlas. India postponed its press review. And suddenly, what began as one agency's delay became a global hush. The question was no longer why NASA waited. It was why everyone else followed. Part 4. The Global Echo. Why the world followed the quiet. Silence has a way of spreading, like ripples across still water. It began with NASA. But before long, it wasn't just them. One by one, the voices that usually filled our feeds with cosmic wonder went quiet. Europe, China, India, even the United Arab Emirates, whose Hope orbiter circles Mars like a silent witness, all stopped releasing updates about 3I Atlas. And for the first time in years, the global conversation about space simply stopped. It was strange, almost poetic. Different nations, different languages, different ideologies, but the same pause. The same careful hush that seemed to say, wait, not yet. What could unite countries that rarely agree on anything in a silence this synchronized? In truth, global space communication is a delicate dance. Every discovery travels through invisible threads, treaties, data-sharing protocols, funding agreements, pride, and politics. When one nation hesitates, the others instinctively do the same, afraid to reveal too much or too early. Take the European Space Agency, ESA. After their Mars Express image showed that mysterious streak, they quietly marked the file pending verification. No press conference, no headlines, just a short internal memo that never saw daylight. Then came China's CNSA. Normally proud to share their Tianwen-1 data, they archived their latest Mars telemetry with no explanation. India's ISRO postponed its scheduled briefing, citing technical review. The UAE's Hope mission, which had just begun to release stunning, high-resolution Mars images every week, suddenly stopped posting. Different nations, different reasons. But one behavior, the silence, echoed perfectly. We've seen this pattern before. In 2021, when the Chinese Zhurong rover discovered a strange reflective material on the Martian surface, photos circulated online for less than 2 hours before being removed from public databases. It took 3 months for a statement to appear, simple, clinical, stripped of emotion. A similar thing happened in 2022, when ESA found irregularities near Europa's frozen crust. Instead of calling it evidence of cryo-volcanic activity, they rephrased it as non-standard surface reflection. The data didn't change, only the language did. That's how global science works now, not through censorship, but through calibration. Every word basuda, every pause measured. Maybe that's the quiet truth behind this global echo. That silence isn't always a lie. Sometimes it's diplomacy. In a world where every discovery becomes a debate, every tweet a headline, and every image a controversy, perhaps humanity is learning to be careful with wonder. Because when you hold something as fragile as truth, you whisper, you don't shout. But whispers don't last forever. Inside the silence, something else was growing: data. Thousands of files, signals, and readings quietly accumulating in observatories and satellites across the planet. Hidden beneath the noise, buried inside the static. And soon, that silence would begin to break. Not through press conferences or politics, but through the data itself. Part 5. Between the Data and the Dark. The Psychology of Silence. Hukum D. Ju I Shong V QH Jia S. When the sky goes quiet, our minds begin to make noise. It's human nature. When faced with the unknown, we fill the silence with stories. Every time the data stops coming, the imagination begins. We draw patterns, invent reasons, even fears. Because sometimes uncertainty feels heavier than the truth itself. There's a strange comfort in knowing, even if what we know is terrifying. But silence? Silence leaves us alone with our thoughts. And that's the kind of space most people aren't ready to explore. The same thing happens in science as it does in life. When information pauses, anxiety rises. Not because we're weak, but because we're wired to seek meaning. Psychologists call this the information void effect. When a trusted source stops speaking, the human brain tries to fill the gap, often with imagination, speculation, or fear. A study from the Oxford Internet Institute in 2021 showed that when governments delayed communication during crises, public anxiety doubled within 48 hours, even if nothing bad had happened. The absence of clarity creates its own form of chaos. And that's exactly what happened when space agencies went silent about 3I Atlas. Within days, the internet filled with theories. Videos claiming alien probes, hidden collisions, secret defense projects. Forums lit up with what-ifs. Because the human mind cannot tolerate an unfinished sentence. We need endings. We need patterns. We need someone to tell us, it's okay, we understand. But the universe rarely does that. It whispers in equations and fragments of light, and it leaves the rest for us to interpret. It's not so different from how we react to silence in our own lives. Think about the last time someone stopped replying to your message. Hours pass, then days. You start wondering, did I say something wrong? Are they upset? Did something happen? Most of the time, nothing's wrong. They're just busy. But the quiet changes how we think. We invent meaning in absence. That's what humanity is doing now, staring at the stars, waiting for an answer that never comes, and trying to make peace with the echo of its own curiosity. Maybe that's the deeper lesson of 3I Atlas. That silence isn't the enemy of knowledge. It's part of it. It teaches us patience, humility, and trust. Trust that the truth, when it's ready, will emerge. The universe doesn't rush, and maybe we shouldn't either. Because sometimes the most profound discoveries aren't found in data. They're found in what we learn about ourselves when the data stops. But silence never lasts forever. Eventually, the numbers began to change. Faint shifts in brightness, irregular pulses, patterns that no one could explain. What started as absence was turning into a whisper, a signal buried deep within the noise. And as scientists leaned closer to listen, They realized that what they were hearing wasn't just random, it was rhythm. Part 6. What the Blur Hides. Physics and the Fuzz. The image was blurry. Too blurry, in fact, for anyone to be certain of what they were looking at. But sometimes, what we call blurry isn't just the fault of the lens. It's the fault of our understanding. Because when the universe refuses to focus, it's often trying to tell us something we're not yet ready to see. Scientists love clarity, clean numbers, sharp graphs, tidy models. But 3I Atlas didn't care about our need for order. It shimmered between frames, brightened and dimmed without rhythm, like a heartbeat trying to sync with something unseen. So what was this object? A comet? An asteroid? A fragment of something artificial? The truth, it turned out, was hiding in the fuzz. Badigi ihadachar rang di haya akita shapiyanishath. When a comet approaches the sun, the heat should cause it to sublimate. That's a fancy word for turning ice directly into gas. The gas forms a glowing shell called a coma, and behind it trails a bright tail made of dust and vapor. It's basic cosmic chemistry, predictable, elegant, and almost poetic. But 3Y Atlas broke that poetry. There was no coma, no tail, no visible trace of gas at all. Instead, its reflection patterns, the way it scattered sunlight, were too clean, almost metallic. Astronomers ran spectral analysis, breaking the light into colors to study its composition. Typical comets have a CO2 to H2O ratio around 2:1. 3I Atlas had nearly 8:1. That's like finding a snowball made of dry ice, something that shouldn't exist naturally in interstellar space. Even stranger, its trajectory wobbled, not enough to call it artificial, but enough to make models collapse. Every time researchers tried to predict its next position, the numbers drifted, as if it were being nudged by something unseen. We've been here before. In 2017, Oumuamua behaved in almost the same way, speeding up slightly as it left our solar system. For months, scientists debated, was it outgassing, a natural phenomenon? Or was it something more? The Harvard physicist Avi Loeb famously suggested it might be a light sail, a thin object pushed by starlight, like a cosmic message in a bottle. His idea was controversial, even ridiculed, but it forced the world to confront an uncomfortable truth. Our universe is still full of things that don't fit our equations. And that's okay. Because progress in science doesn't begin with certainty. It begins with confusion, with a blur we can't quite sharpen yet. Maybe that's what 3I Atlas came to remind us. That even in an age of high-definition telescopes and quantum equations, wonder still lives in the places we can't explain. The blur isn't the enemy of knowledge. It's the birthplace of curiosity. Just because we can't see clearly doesn't mean nothing's there. It might mean something extraordinary is waiting for us to look differently. And as the scientists looked differently, one name began to reappear. A man who had once been mocked for asking impossible questions. A voice that had dared to say, maybe we're not alone, and maybe that's not a bad thing. Soon, the blur would have a human face and a theory bold enough to shake the silence. Part 7, the Loeb equation. A rebel's view of the cosmos. Every field has its rebel, the one who asks the question everyone else avoids. In modern astrophysics, that rebel has a name, Avi Loeb. To some, he's a dreamer. To others, a troublemaker. But to those who still believe curiosity is sacred, has something rarer, a scientist who refuses to stop wondering out loud. When Oumuamua raced past Earth in 2017, Loeb saw what others dismissed, a mystery worth defending. He asked the forbidden question, what if it wasn't a rock, but a message? Most laughed, a few listened, and quietly, the world took note. Because while others saw a blur of light, Loeb saw a possibility, that the unknown might not be chaos but design. Avi Loeb was the head of Harvard's Department of Astronomy, a man who had spent decades studying black holes and the early universe. He wasn't a fringe thinker. He was the establishment. But when Oumuamua's data refused to fit conventional models, no gas, no tail, irregular acceleration, Loeb didn't try to force it into an old box. He built a new one. He proposed it could be an artificial object, maybe a light sail, a relic from another civilization, drifting across galaxies like a lost thought. His peers called it speculation. Some called it career suicide. But Loeb didn't back down. He said something most scientists are too careful to say. If we ridicule every idea that challenges us, we'll miss the discoveries that could redefine us. Then, in 2021, he launched the Galileo Project, a privately funded effort to systematically search for physical evidence of extraterrestrial technology. No hype, no conspiracy, just science, free from politics and fear. In an interview, a journalist once asked him, "Do you ever worry about being wrong?" Loeb smiled and replied, "Every day." That's why I love science. Being wrong is how we grow. That sentence, simple, human, humble, may be the most important equation he's ever written. Because in a world obsessed with certainty, Loeb teaches the courage of curiosity. The willingness to stand alone in the silence and still ask the question. Maybe that's what we all need. Not to be right, but to be brave enough to wonder. To admit that the universe doesn't owe us answers, but still, we keep asking. Because progress isn't made by those who know everything, it's made by those who dare to admit they don't. And maybe that's the Loeb equation after all. Curiosity, fear equals discovery. Loeb's voice sparked something. Suddenly, amateur astronomers, private observatories, even independent research groups began turning their lenses toward the silence. If governments wouldn't speak, perhaps individuals would. And in the coming weeks, the quiet night sky would become alive again. Not with official press releases, but with thousands of private eyes looking up and seeing something they weren't supposed to. 8. Hidden eyes. The private telescopes you've never heard of. Not all telescopes belong to governments. Some sit quietly on rooftops, in backyards, or on remote desert plains, pointed at the same sky, searching for the same truth. They don't have billion-dollar funding or press departments. They don't chase fame or validation. They just watch. These are the hidden eyes of the world, the private telescopes you've never heard of, but that might already have seen more than any of us realize. Inspired by voices like Avi Loeb, small observatories and amateur astronomers began turning their lenses toward the silence. They weren't waiting for permission. They weren't waiting for press conferences. They simply wanted to know. And so, While official agencies stayed quiet, a new map of the night sky began to form, built not by institutions, but by individuals. Today, more than 12,000 private telescopes are connected through online networks, quietly scanning the heavens every night. Some belong to universities, some to retired engineers, some to teenagers who saved for years to buy their first CCD camera. They share data through open channels like the Las Cumbres Observatory Network, Planet Labs, and countless online sky surveys. And sometimes these small eyes capture what the big ones miss. In 2023, one of Planet Labs' Earth observation satellites accidentally recorded a massive volcanic eruption in Tonga 3 months before the data was analyzed. The footage sat unnoticed in their servers, hidden by algorithms trained to ignore non-terrestrial events. It wasn't until an amateur researcher stumbled on it that the full scale of the eruption was revealed. And in 2024, a network of private telescopes in Chile picked up a sudden brightening near Jupiter's orbit, data that later helped refine models for 3Y Atlas itself. While the headlines stayed quiet, the sky had already been whispering. Some of these watchers are just ordinary people. Like Maria Alvarez from Argentina, a high school teacher who spends her evenings capturing comet trails with a small telescope she calls Luna. Or Tom Richards in New Zealand, who built his own observatory out of recycled parts and shared his findings online for free. When asked why they do it, their answers are simple. Because looking up reminds me that I'm part of something bigger. Because someone has to keep watch. It's not about proving anyone wrong. It's about keeping the wonder alive in a world that sometimes forgets to look up. Maybe that's what these hidden eyes teach us, that truth doesn't only belong to institutions. Curiosity isn't a privilege, it's a birthright. And when enough ordinary people decide to care, silence doesn't stand a chance. Because every great discovery begins the same way, with someone, somewhere, quietly pointing a telescope toward the dark and whispering, "What if?" But not everyone found comfort in this new light. As the private networks grew louder, something else began to stir. A quiet unease among the world's governments. Because curiosity, once unleashed, is hard to contain. And soon, what began as science would start to look like strategy. Part 9. Cosmic Statecraft. Why governments fear the unknown. Knowledge is power, and power never travels quietly. The moment curiosity becomes collective, it starts to look like something else. Influence. And influence in the wrong hands feels a lot like threat. So when private telescopes began revealing what governments weren't ready to discuss, the silence wasn't just about science anymore. It became about control. It's strange, isn't it? We celebrate discovery, but only when it's convenient. We fund curiosity, but only when it fits the narrative. And yet, the universe doesn't obey narratives. It doesn't care who's in charge or who gets the headline. It just is, and that's precisely what frightens those who build their strength on certainty. For governments, the unknown is more than mystery. It's instability. A sudden anomaly in the sky can shake markets, rewrite security policies, or even shift alliances. Think of 2020, when the Pentagon quietly released videos of unidentified aerial phenomena. They weren't announcing aliens. They were acknowledging uncertainty. And that single act reshaped conversations about national security around the world. Because once you admit you don't control the sky, you've admitted that something else might. History repeats this pattern. In 1952, the U.S. Air Force launched Project Blue Book, an investigation into thousands of UFO sightings. For years, they denied everything, not because they had proof, but because they feared the absence of it. How do you govern fear that has no name? Even today, many agencies use what insiders call communication choreography. Deny first to buy time. Deflect second to reframe the question. Drip release third to control how truth unfolds. It's not deception. It's diplomacy, the kind that protects stability more than honesty. You can see the same thing in smaller ways, too. When scientists at a national observatory discover something unusual, they often need clearance before publishing. Not because of secrecy, but because information causes reaction. One astronomer once said, "If we find life out there, my first phone call isn't to the media, it's to the policy office." That's the reality of cosmic statecraft. Even wonder has a chain of command. Maybe that's the paradox of our age. We build rockets to touch the stars, but we're still learning how to face what they might reveal. The unknown doesn't just test our technology. It tests our humility, because truth is powerful. And power, when unprepared for truth, chooses silence. Perhaps governments don't really fear the universe. They fear what it might ask of us. Cooperation, unity, honesty, things that politics rarely reward. But while the world's leaders hesitated, the object itself didn't. 3I Atlas kept moving, silent, constant, radiant. And as it drifted beyond Mars, a new idea began to rise among scientists. What if silence wasn't caution anymore? What if it was camouflage? Part 10, the stealth hypothesis. What if the probe is hiding? What if we were never alone, just unaware? What if the silence of space isn't emptiness, but discretion? Some scientists have begun to wonder if 3I Atlas isn't just quiet, but intentionally so. A visitor passing unseen. Not because it can't be detected, but because it doesn't want to be. It sounds like science fiction, doesn't it? A probe drifting through the dark, hidden beneath layers of ice or dust, watching, learning, waiting. But the truth is, the idea of stealth probes isn't fantasy. It's physics, and it's older than we think. Back in the 1960s, an engineer named Ronald Bracewell proposed a daring idea. If another civilization wanted to study us, they wouldn't waste energy shouting across the galaxy. They'd send a small, silent probe, a listener, designed to hide near habitable planets and simply observe. Decades later, we did something eerily similar. NASA's Voyager and Pioneer probes are drifting through interstellar space right now, carrying golden records, messages of music and greetings, hoping someone, someday, will notice them. They are our own lurker probes. So perhaps it's not so strange to imagine the same from somewhere else. A device cloaked in dust, wrapped in frozen gas, reflecting almost no light, camouflaged perfectly against the cosmic background. To our telescopes, it would look like an ordinary comet. To them, it would be the perfect disguise. Even Avi Loeb's Galileo project has quietly begun simulating how such probes might appear. non-reflective, tumbling irregularly, moving just slightly off predicted paths, exactly like 3i Atlas. We've built our own stealth machines too, spacecraft coated with radar-absorbing paint, satellites programmed to avoid detection, autonomous rovers designed to study without interfering. We hide to learn. Because sometimes, the best way to understand something is not to disturb it. Maybe, if someone out there has been watching us, they're doing what we would do, listening quietly, wondering whether we're ready to listen back. And maybe they've already seen our golden record, heard our music, our laughter, and decided that the kindest thing to do is stay hidden. Perhaps stealth isn't a sign of threat, but of respect. The silence might not mean you're not worth speaking to, but rather you're still becoming who you're meant to be. It's a comforting thought that even in our mistakes, our wars, our noise, someone might be watching with patience, waiting for us to grow wise enough to meet them halfway, because true intelligence doesn't rush revelation, it listens until the student is ready for the teacher. And so, as 3i Atlas drifts beyond Mars, scientists continue to record its faint flickers, its unpredictable light, its quiet rhythm. But somewhere beyond the data, beyond the numbers, a deeper reflection begins to take shape. If we are being watched, then maybe the question isn't who is watching, but what does our behavior say about us? Part 11. When the sun speaks and humanity listens, not all silence is cosmic. Sometimes it comes from much closer, from the star that gave us life. Because the sun doesn't just shine, it speaks. In flares and pulses and solar winds and magnetic whispers, every burst, every flicker, every storm is a message. And lately, those messages have grown louder. Maybe the universe doesn't need to send us visitors. Maybe it's been speaking all along through the one presence we always see but rarely listen to. The question is, when the sun speaks, do we truly listen? In 2025, solar scientists began noticing an unusual rhythm in the sun's behavior. Sunspot activity surged faster than predicted. Auroras reached as far south as Florida and Rome, glowing rivers of light across skies that hadn't seen them in a century. NASA and ESA confirmed. We were entering one of the most powerful solar cycles in decades. But this wasn't just science. It was a reminder, a humbling one, that we live inside a living system, a star's heartbeat that shapes our days, our technology, even our moods. When a solar flare erupts, it can knock out satellites, disrupt GPS, even darken cities. But it also paints the sky with color, sends invisible energy cascading through our magnetic field, and reminds us of something simple, that the sun isn't just a background, it's home. And in a strange way, the timing felt poetic. As the world argued over silence in the cosmos, our own star began to sing. In March 2025, during one of the largest geomagnetic storms in modern history, an amateur photographer in Iceland captured a rare moment, auroras shaped like spiraling wings, dancing right above the constellation where 3i Atlas had last been seen. He said, "It felt like the sky was responding." Of course, scientifically, it wasn't. But symbolically, spiritually, it felt true. The sun's voice, the earth's shimmer, humanity's awe, all connected in a single conversation of light. Maybe that's what the sun was trying to say all along, that we don't need to look to the stars to find wonder. It's already here in the warmth that wakes us, in the light that feeds us, in the pulse that beats through every atom of life. The sun reminds us that not all signals are hidden. Some truths are so bright, we simply forget to notice them. And perhaps, before we reach for other worlds, we should learn to listen to the one voice that's been guiding us since the beginning, the voice of our own star. But as the sun sang louder, another kind of reflection began to grow. Not from telescopes or satellites, but from within us. Because in chasing the mysteries of the cosmos, we had begun to uncover a greater mystery, what those mysteries say about who we are. Part 12. Beyond Silence. Lessons from the Invisible Universe. Every mystery begins in darkness, but not every darkness is empty. Sometimes the things we can't see, the quiet forces, the unseen patterns, the faint signals between the stars, are the very threads that hold the universe together. For centuries, humanity has searched outward, pointing telescopes at the sky, sending probes into the void, listening for a sound that might prove we're not alone. But maybe, just maybe, the universe has been asking us the same question all along. Are you listening to yourselves? Modern science is slowly discovering what ancient wisdom has whispered for ages, that the invisible often carries the greatest weight. Dark matter makes up 85% of the universe, yet we've never seen it, only its gravity, bending the light of galaxies like fingerprints pressed into fabric. Neutrinos, those ghost-like particles, pass through our bodies by the trillions every second, unseen, unfelt, yet essential. Gravitational waves ripple through space-time, carrying stories of stars that died billions of years ago, and we only just learned how to listen. Maybe 3. Atlas belongs to this same family of invisible teachers. A reminder that what we call silence may simply be a language we don't yet understand. Every unknown is an invitation not to conquer the universe, but to expand the way we listen to it. In 2015, when scientists detected the first gravitational waves, no one could see them. There was no light, no image, only a faint vibration, a whisper in the fabric of space itself. And yet, that invisible sound confirmed a truth Einstein had predicted 100 years before. A truth that existed long before we were ready to hear it. It wasn't the data that changed humanity that day. It was the humility, the realization that the universe had been speaking all along. We had just learned to listen in a new way. Perhaps that's what 3i Atlas and all these cosmic silences are here to teach us. That discovery isn't about noise. It's about awareness. That progress isn't about control. It's about connection. And that faith, whether in God, in science, or in each other, is really the same act. A quiet choice to believe that the unseen still matters. Because somewhere between what we can measure and what we can feel, between data and wonder, between silence and song, there lies understanding. And maybe that's the true message of the invisible universe. We were never searching for aliens, we were searching for ourselves. And slowly, beautifully, we're learning how to listen. As 3i Atlas fades beyond the edge of sight, its light grows smaller, but its question remains. The question isn't, are we alone? It's, are we awake? And in the stillness of the cosmos, as data turns to story and silence turns to meaning, perhaps the universe finally whispers back, you were never alone.